Hi there, and welcome to the Checkpoint Jumpstart training program on CloudGuard workload protection. My name is Levi, and I will be your trainer in this program. Before we get down to business, let's run through the program's outline. The purpose of this program is to give you an insight into the cybersecurity challenges involving the protection of workload in the cloud, and Checkpoint solutions for these challenges under the CloudGuard umbrella.
By the end of this program, you will be able to describe the cybersecurity challenges faced by workloads in the cloud, describe Checkpoint's solutions for protecting workloads, describe the steps required to deploy the various CloudGuard workload protection solutions, and perform light deployments of the various CloudGuard workload protection solutions. The program consists of the following sessions: this introduction session, which you are watching right now, a short introduction to workload protection. Then we'll have solution-specific sessions, starting with CloudGuard Container Security, CloudGuard Shift Left, CloudGuard Serverless Security, and CloudGuard AppSec. Finally, we'll summarize this program and suggest some further resources. For the sake of efficiency and in order for this training program to succeed, it is assumed that you're familiar with the following concepts: cloud computing and the workload concept, Kubernetes terminology including cluster, node, pod, and container, Docker container, serverless functions, Nginx web server and reverse proxy, and the CI/CD pipeline. So if you're unfamiliar with some of these concepts, please make sure to brush up on them before taking this program. It would also be beneficial if you are familiar with the AWS and Azure platforms, technologies, and concepts, as we'll be exhibiting some deployments using examples relevant to these platforms.
And that about wraps up this session. We wish you good luck in this program and hope you find it both useful and enjoyable. And I'll see you in the next session. Welcome to the short introductory session to workload protection. In this session, we'll take a high-level look at the threat landscape concerning cloud workloads, and we'll briefly lay out CloudGuard's advanced capabilities for protecting workloads.
By the end of this session, you will be able to describe the cloud workloads and application security threat landscape, and you'll be able to describe in general terms how CloudGuard protects workloads and applications. So, where do we begin? As we know, moving from an on-prem mindset and implementation to the cloud means a shift from a monolithic approach where services and applications are fully hosted on servers supplying all the resources needed to a dynamic, decentralized approach comprised of microservices which have the potential of being scattered across multiple platforms, environments, and resources. Infrastructure elements that were static in the corporate data center are now abstracted to software in the cloud, and their entire life cycle may only be a matter of minutes or seconds, what is known as ephemeral. On top of this abstraction, decentralization, and scattering of IT components, the management of various components becomes decentralized as well. Instead of just one IT department to manage, execute, and monitor, we have multiple cross-departmental teams who can deploy, manage, and modify resources, services, or applications. This evolution comes with a slew of security challenges that are unique to cloud deployments. The more decentralized a system is, the broader its attack surface. There are simply more components, assets, and mechanisms that may be exposed. Additionally, deploying multiple cloud accounts created by different teams for different applications means that there are simply many more targets of attack that might be compromised due to the human factor. All it takes sometimes is one misconfiguration of a resource or an account, and the road is paved for exploitation. Since cloud deployments may stretch over a vast array of platforms and environments, with multiple assets and multiple personnel responsible for various aspects of deployment and management, this may lead to deficiency in visibility and tracking. Invisible and unmanaged assets can create large gaps in security enforcement. Cloud assets are provisioned and decommissioned dynamically in large scale and in fast pace. Traditional security tools were not developed for the cloud and thus cannot enforce policies in such flexible environments. The faster than ever pace of the DevOps process around application deployment and server provisioning increases the risk of coding mistakes and exploit being shared automatically in this work culture. This rapid pace leaves little room for errors. In multi-cloud deployments, applications are deployed across multiple cloud providers. Vulnerabilities and mitigations differ between cloud providers. It becomes a challenge to create a consistent security policy across those deployments. Finally, cloud-delivered systems must be cloud compliant. That is, be in compliance with the industry standards, regulations, and best practices. Now that we've described cloud security challenges in general, let's focus on the specific challenges faced by cloud workloads, which naturally stem from the aforementioned challenges. First, for the sake of being on the same page, let's define. Workloads are the containers, functions, or machines that store the data and network resources which make an application work. In other words, they are the resources and processes required to execute an application, service, or other functionalities. Containers provide a consistent, isolated execution environment for applications. They are similar to virtual machines, yet they do not require a guest operating system. Instead, the application and its dependencies are packaged into a container based on an image, and then a standard runtime environment is used to execute the app. This allows the container to start up in just a few seconds because there's no operating system to boot and initialize. You only need the app to launch. The current dominant system for automating deployment, scaling, and management of containerized application is Kubernetes. It allows a company to get the same user experience regardless of the designated cloud provider. Every cloud provider has its own version of Kubernetes, for example, AKS, EKS, and GKE. Container environments elicit a range of cybersecurity issues. You must secure images, containers, hosts, runtimes, registries, and orchestration platforms. Container security is made more complex by the high quantity of containers most organizations have and the frequency with which they are updated. Each update is an opportunity for vulnerabilities to be introduced. Additionally, most images which containers are based on, even those that are custom-made, are built on third-party code and thus at risk of third-party vulnerabilities. Serverless functions, on the other hand, are single-purpose, event-driven functions that are triggered only in response to an event, such as receiving an HTTP request. The code executes in a fully managed environment where there is no need to provision any infrastructure or worry about managing any servers. This takes the abstraction of containers up a notch. Comprised of dozens or hundreds of functions, serverless applications are tiny microservices with their own policies, roles, API, audit trail, etc. This changes the attack surface. Instead of a small number of entry points with a lot of functionality hidden behind each one, there are now more entry points, each with a small part of the app behind it. Defending your application now requires thinking about each entry point. Additionally, most of these functions are provisioned with more permissions than they require. Overprivileged functions enlarge the attack surface as well as potentially increase the impact of an attack. The short duration of serverless functions means that serverless security threats may change shape. Attackers may construct a much shorter attack that just steals, for example, a few credit card numbers. Finally, the lightning speed nature of serverless functions execution requires adequately fast security processing. Any delay in execution due to protection and inspection will defeat the purpose of using this rapid mechanism. In the face of all these workload protection challenges, we have CloudGuard on our side. CloudGuard Workload Protection, which is part of the CloudGuard native security platform, provides a unified view of container assets across all cloud environments to ensure configurations are in compliance with known baselines such as CIS, Kubernetes Security Benchmarks, or NIST 800-190. In addition, security and compliance configurations can be built into CI/CD to automate container security during development. During runtime, CloudGuard protects the container assets using dynamic protection based on customized rules, behavioral analysis, as well as other threat intelligence modules, automating protection and remediation. CloudGuard's breakthrough code-centric platform automates security and visibility for cloud-native serverless applications from development to runtime, enabling organizations to securely innovate at cloud speed. By analyzing the serverless application code before and after deployment, organizations can achieve a continuous serverless security posture, automating application hardening, minimizing the attack surface, and simplifying governance. Utilizing machine-based analysis and deep learning algorithms, CloudGuard builds a model of normal application and function behavior to detect and block application layer attacks for enhanced serverless security. Up to this point, we've covered the security threats cloud workloads face and how CloudGuard can help protect against them. But what about the applications themselves? What about the APIs used to interact with cloud resources and services? How do we protect these elements? First, let's take a moment and talk about the threats we face in these areas. Web applications face a broad range of possible attacks described in the OWASP Top 10 standard. The decentralized nature of cloud implementations and the speed and scale of working in the cloud means apps are prime targets for various malign activities, from code injection to broken access control, coupled with a lack of sufficient logging and monitoring. These attacks can result in site defacing, information leakage, digital theft, and user session hijacking. In the realm of APIs, command injections and API key extraction can lead to exposure of sensitive data and the hijacking of resources. Furthermore, malicious bot attacks using automated web requests can be used to manipulate, defraud, or disrupt a website, application, API, and even end users. Traditionally, you would use a legacy web application firewall to defend against these kind of attacks. These WAFs are rule-based and use binary rules to match requests to attack signature databases. This creates enormous administrative overhead and blocks legitimate application users, or as we like to call it, false positives. Faced with these threats and the gap left by legacy WAFs, CloudGuard AppSec can stop OWASP Top 10 attacks, prevent bot attacks, and stop any malicious interaction with applications and APIs across any environment. CloudGuard AppSec is fully automated and leverages contextual AI analysis to provide precise threat prevention for modern web applications, lessening the need for ongoing administration and increasing applications security at scale. Gone are the days where rules had to be tuned manually with exceptions every time an update to the web application or API was necessary. From implementation through runtime, CloudGuard AppSec automatically analyzes every user, transaction, and URL to create a risk score to stop attacks without creating false positives. And there you have it. We've gone through the major security challenges we are faced when implementing cloud services and applications and the specific threats targeting cloud workloads, applications, and APIs. And we introduced CloudGuard's solutions to these complex, ever-evolving challenges. In our next session, we will start drilling down into CloudGuard's workload protection and see how we can perform a deployment. We will start with protecting containers. Thank you for taking this introductory session. I hope you enjoyed it, and I'll see you in our next one. Welcome to this session on CloudGuard Container Security. In this session, we'll take a deeper look at CloudGuard Container Security and how it is deployed. By the end of this session, you will be able to describe how CloudGuard runtime protection, image assurance, and admission control work to protect containers, and you'll be able to perform an initial deployment and configuration. As we know by now, due to the sheer complexity and decentralization of cloud deployments, containers can be vulnerable to exploitation. To help protect against malicious attacks targeting containers, Checkpoint offers its container security as part of its workload protection suite. This protection hardens cloud workloads by detecting overly permissive roles, vulnerabilities, and embedded threats. It automates runtime protection, providing multi-layer security, leveraging machine learning to profile and protect workloads. And it supplies governance and DevSecOps, enforcing granular security policies during CI/CD and production. CloudGuard monitors in real time the kernel system calls that workload containers perform. Runtime protection is a combination of two engines, signatures and profiles. The signature engine monitors the kernel system calls performed and compares them with known signatures that potentially indicate malicious behavior. For example, execution of processes associated with crypto mining software. The profile engine detects anomalies in behavior compared to a baseline profile, which is based by default on a learning period of 24 hours. Every time one of the containers of a given pod group performs an operation not observed during the profiling phase, a violation is detected and an alert is generated. Runtime protection includes the following resources. The Runtime Policy Agent. This agent is responsible for retrieval of user-defined configurations and policies from the CloudGuard backend. The Runtime Daemon. This is a Kubernetes daemon set which, as explained, runs the two runtime protection engines. The daemon monitors the kernel system calls. The last runtime protection resource is Custom Resource Definitions, also known as CRDs. These are runtime protection policies which define allow, deny, and exclusions. These CRD policies are present on any cluster our solution resides. So, once deployed, the flow would look like this. A node's runtime daemon requests information from the cluster's API server to determine which pods are running in the cluster and the processes that are running. These processes are basically system calls to the cluster's kernel. Meantime, the CRDs are constantly updated with valid signatures and profiles the Runtime Policy Agent retrieves from the CloudGuard backend. When a kernel system call is made by a protected asset within the cluster, its runtime daemon monitors the call and examines its validity against the CRD definitions. If there's a deviation from the policies defined in the CRDs, an alert is sent to the CloudGuard backend. When onboarding a Kubernetes cluster with runtime protection, CloudGuard automatically adds a default security policy and rule sets for the cluster environment. You do not need to perform any additional actions unless you would like to create specific exclusions. So we talked about runtime protection for containers, but what about the images they are based on? CloudGuard Image Assurance analyzes Kubernetes images in runtime to make sure they are free of known vulnerabilities and compromised repositories. The image assurance agents continuously check the cluster for all deployed images. If an agent identifies an unknown image, the agent scans and analyzes the image to find vulnerabilities, exploits, malware, viruses, trojans, credential leakage, and other malicious threats. Image assurance uses the following resources. The image scan engine, which is responsible for analyzing and scanning the image locally. This agent sends the backend the necessary information to complete the scan. And the image scan daemon, which is a Kubernetes daemon set that checks the local registry on every node to find the deployed images on the node. So, once deployed, the flow looks like this. Regardless of CloudGuard, for pod redundancy purposes, Kubernetes saves container images locally in the cluster for every pod it handles. In each of the cluster's nodes, CloudGuard maintains an image scan daemon, which scans the list of locally stored images by calling the cluster's internal container registry. This information is relayed to the image scan engine, which is then relayed to the backend. The backend then examines and validates the list of images. If it detects an unknown image, it reports this to the image scan engine. The engine then requests the image scan daemon to fetch the image in question from the registry. After its retrieval, the image scan engine unpacks the image, analyzes it locally, and sends its metadata to the backend. The detection verdict is then presented in the CloudGuard portal. You can view the findings in the CloudGuard native portal under Images, where you can drill down into the Posture Findings tab. You can also see the vulnerability findings for all clusters in the account by navigating to Image Assurance Vulnerabilities. When the process of onboarding a new Kubernetes cluster with image assurance is complete, or when image assurance on a Kubernetes environment is enabled, CloudGuard automatically adds a default policy and rule sets for the cluster environment to issue image assurance findings. You do not need to perform any additional actions. CloudGuard creates these findings when it scans the image for the first time. Then the CloudGuard portal checks it periodically for changes or newly discovered vulnerabilities. But what about the API calls to the Kubernetes cluster? Understandably, some calls may either be malicious in nature or come from an unauthorized source. CloudGuard's admission controller stops malicious or inadequate requests to the Kubernetes API server before they become persistent. Based on the controller's decision, the request can be immediately rejected and an error is returned to the end user. The CloudGuard admission controller utilizes a Kubernetes validating admission webhook to enforce the policies created by the users in the CloudGuard native portal or via CloudGuard APIs. The admission controller consists of the following resources: the policy agent, which is responsible for retrieving configuration and policies configured by the user from the CloudGuard backend. The enforcer agent, which establishes the admission webhook, receives the API calls and validates them based on the enforced policy. And finally, the CRDs, which consist in this case of detection and prevention rules for each supported Kubernetes object type, such as pods, jobs, roles, etc. Access to these CRDs, including read permissions such as get and list, should be restricted, as they contain information on the cluster security. So, once deployed, the flow looks like this. The policy agent retrieves user-defined admission criteria based on configurations and policies from the CloudGuard backend, and updates the CRDs accordingly. Once any API request to the Kubernetes cluster API server comes in, it is intercepted by the enforcer agent. The enforcer agent evaluates the API call, making sure it is not malicious based on the CRD definitions. Depending on the settings, if the call is malicious, it can either be just detected and reported, or detected and blocked. So for instance, only DevOps has permission to connect via SSH to a pod protected by CloudGuard. So the API call will be permitted to pass by the enforcer agent to the API server. API calls from all other sources in this case will be dropped before the API call is completed. Unlike the previously discussed components, for admission controller to function, it requires proactively adding a policy rule set. Later on, when we get to this part of the deployment, we'll look at how we can add such a rule set. An additional component we can enable during the deployment process is threat intelligence. CloudGuard delivers advanced security intelligence, including cloud intrusion detection, network traffic visualization, and cloud security monitoring and analytics. It combines cloud inventory and configuration information with real-time data monitoring from a variety of sources from Amazon AWS, Microsoft Azure, and Google Cloud Native Log, packet capture, appliance, and alert tools. The outcome is rich contextualized information, enhanced and simplified visualization, deep event correlation, querying, intrusion alerts and notification of policy violation, enhancing security operations centers with relevant cloud security intelligence for faster and more efficient incident response. Finally, the last component that is enabled during deployment is CloudGuard Cloud Security Posture Management. This component is baked into the solution, so you need not enable it proactively. Posture management automates governance across multi-cloud assets and services, including visualization and assessment of security posture, misconfiguration detection, and enforcement of security best practices and compliance frameworks. Check out our dedicated program on CloudGuard Cloud Security Posture Management for a deeper dive. Now that we've covered the various components of CloudGuard workload protection that can be deployed to help protect containers, let's roll up our sleeves and start deploying. Deploying CloudGuard container security is rather straightforward. We will synchronize CloudGuard and the Kubernetes cluster by deploying a CloudGuard agent onto the cluster, which reports information back to CloudGuard. On top of that, we will have to configure the admission controller component from scratch to create default access rules. For the sake of this session, we're assuming you already have a Kubernetes cluster set up, as this is out of this program's scope. To begin, we log into the Infinity portal and navigate to the Assets section under CloudGuard. Here, we need to connect CloudGuard and the Kubernetes cluster we wish to protect. We start by adding a new Kubernetes cluster environment. If this is the first time we're adding an asset, we'll get this Get Started screen. Otherwise, we'll add a new environment into the existing list of environments. We fill in a meaningful, unique name which will be used to identify the Kubernetes cluster within CloudGuard. Next, we create a new service account which will generate the account API key ID and secret. These will be used to identify the API calls from CloudGuard's implanted agent in the cluster to CloudGuard. It is important to keep a record of these details for future reference. Note that you can also use an existing service account. In such a case, you'll be using the API key ID and secret on record. Next, we fill in the Kubernetes namespace as defined in our target cluster. We make sure to mark the desired features we'd like to make available. Now, we choose the relevant organizational unit to associate with a cloud account. Organizational units help us view and maintain onboarded accounts according to logical groupings, such as business units or geographical regions. Next, we open an SSH connection to the designated Kubernetes cluster and paste the Helm commands from the instructions summary in the SSH connection. These commands deploy the CloudGuard agent within the cluster. Once done executing, the status will be deployed. Clicking the Next button will verify that both systems are synchronized. This synchronization means CloudGuard accesses the cluster through the agent to obtain information about the assets. To finalize, we hit the Finish button. This completes the deployment. We now have our CloudGuard workload protection deployed and synced with our Kubernetes cluster. Let's look at what we have here. Under Protected Assets, we can view the onboarded account's assets. CloudGuard fetches information about these assets from the onboarded cloud platform and presents it in a console view. CloudGuard monitors the security posture of these assets. Drilling down into a workload asset, we can view its protected processes, define exclusions to the default runtime protection rules, and find any special security findings and events related to the asset. Conversely, we can access the protected components through workload protection. Here, we can view and drill down into all containers being protected across the board. Under Image Assurance, we can locate the images being protected, view any detected vulnerabilities, and examine and modify the default policy and rules. Here, we can view and drill down into all the pod groups runtime protection is applied to across the board. Under Admission Control, we need to create a first-time rule set, as the deployment does not create a default policy. This process consists of 3 steps. Adding an admission control rule set, adding rules to the rule set, and adding an admission control policy that binds the rule set to the cluster. Let's add an admission control rule to prevent services from being publicly exposed. Naturally, your use cases can differ depending on your architecture and business needs. We start by adding a rule set and naming it. Now, we add a new rule into it. When we click inside the GSL box, the GSL editor opens up. CloudGuard GSL, which stands for Governance Specification Language, is a simple yet expressive syntax to define rules, which can be included in rule sets in the CloudGuard compliance engine. The use case option covers the most popular scenarios for the admission control rule set creation. In this case, we add this pre-built rule. You can see the GSL syntax change as we further configure the rule. Finally, we verify the rule against the relevant environment and save. Now, we need to bind the rule set to the relevant cluster. So, we head out to the policies and either associate it with an existing policy or with a new policy. In our case, we'll create a new policy. After defining which entities it applies to, we need to choose one or two actions to take when the rule or rules within the policy are violated. Either detection, where the policy does not block events on the cluster but sends an alert notification, or prevention, where the policy blocks an event that violates it on the cluster and sends an alert notification. It's best practice to first use detection with new policies. If needed, you can configure multiple policies on the same cluster with a different action configuration. Finally, we define one or more notifications to receive when the policy is violated. In case synchronization fails during the deployment, check that the agents are in a ready state by inputting the following commands to your Kubernetes cluster, where namespace is your Kubernetes namespace. And there you have it. We've gone through the CloudGuard components protecting containers, as well as the easy and straightforward process of deploying this solution onto a Kubernetes cluster. In our next session, we'll explore the shift-left concept of protecting workloads during the CI/CD pipeline process before they are deployed. Thank you for taking this lesson. I hope you enjoyed it, and I'll see you in the next one. Welcome to this session on CloudGuard Shift Left. In this session, we'll explore CloudGuard's Shift Left solution for shifting security to the left and how it is deployed. By the end of this session, you will be able to describe why CloudGuard's Shift Left is needed and how it works, and you'll be able to perform a basic deployment of CloudGuard Shift Left. Now that we've discussed deployment and configuration of the various container protection components, which relate to runtime, let's discuss the importance of shifting left and how CloudGuard Shift Left enables this. Shifting left refers to moving security sooner in the development process. Instead of only protecting assets in runtime, shifting your security to the left preempts misconfigurations and vulnerabilities in your asset during the CI/CD pipeline process before it is deployed. CloudGuard's solution for shifting left is called Shift Left, and it brings the CloudGuard security abilities to detect and prevent risks in cloud deployments while in the CI/CD pipeline. Shift Left scans infrastructure as code templates for risk, checks software for known vulnerabilities, and scans container images for security issues. It also provides a single interface for multiple CI/CD security steps. Instead of being forced to fix in production, developers are notified of issues immediately. Shift Left runs a pre-configured security policy rule set or rule sets to examine the destination of choice, be it an infrastructure as code template, such as a Terraform template, the software being developed, and/or container images. Shift Left can be executed either on demand or automatically as part of the pipeline execution. The end result of executing Shift Left is a stop-go action in the pipeline. The pipeline's execution moves to the next step upon a Shift Left OK. And if everything passes, the pipeline is completed. Otherwise, depending on the instructions, the execution will stop, and the relevant developer will be alerted about the failure and its cause. With this in mind, let's take a look at the process of deploying shift left. First, since the shift left arguments refer to rule set numbers within your CloudGuard native security policy, you need to make sure your relevant shift left policies are set up and make it clear to yourself which rule sets you would like to run against the examined destination. Now, you need to decide how you would like to execute shift left in your CI/CD pipeline examination. You can download the shift left CLI tool from the CloudGuard native portal and run the desired commands locally and on demand to get a feel for how the tool works, or you can automate its execution in your pipeline tool of choice. Let's first focus on the on-demand shift left scanning. If you're intending to run the shift left tool, browse to shift left in the CloudGuard native portal and walk through the wizard. It will prompt you to download the shift left executable. You can download an executable for Windows, Linux, or Mac, plus a containerized version is also available at the Docker Hub repository under Checkpoint Shift Left. Then, you'll need to generate an API key and secret to be incorporated into the API calls connecting between the shift left CLI to the CloudGuard backend. This is followed by a set of commands to make this information available to the tool via environment variables. Once done, you can go ahead and fire away desirable shift left commands to examine the posture of your protected assets. So, how does such a shift left command look like? In general, commands first need to address the destination blade, either the code scan blade, the image scan blade, or the IAC assessment blade. This is followed by the argument and the desired parameters supporting the argument. So for instance, we can scan an image with the image scan blade pertaining to the following command and parameters. R stands for the rule set. Alpine.tar stands for the image name to be scanned. And E stands for the CloudGuard native shift left environment, followed by the environment ID. If it is detected that there's a deviation from the rule set, the tool will list the reason or reasons. So, a possible result of our image scan could look like this. For a comprehensive list of arguments and syntax, please refer to the documentation page, Shift Left, using the CLI tool. To better understand the output of running Shift Left, and for automation of various usage scenarios, check out the complete list of error codes that might appear during the execution of Shift Left. This can be found on the documentation page, Shift Left Error Codes. Incorporating Shift Left automatically into the pipeline process would be the desired path of DevOps or DevSecOps in a real-world setup. This method requires a one-time setup on the desired automation platform. In the following example, our repository is hosted on GitHub, and the pipeline automation is performed via GitHub Actions by executing main YML. In this case, we're running a containerized version of the Shift Left tool, which resides on Docker Hub. Upon any change to a repository asset, a full set of Shift Left inspections is initiated on all three blades. Note that you will also need to incorporate the API key and secret into the YML configuration file by using repository secrets. And there you have it. Implementing Shift Left protection is pretty straightforward and flexible, and ensures you can preempt configurational errors or deployment of malicious code or images into your production, way before runtime protection is employed. In our next session, we'll explore the other part of the CloudGuard workload protection solution, serverless functions. Thank you for taking this session. I hope you enjoyed it, and I'll see you in the next one. Welcome to the session on CloudGuard serverless security. In this session, we'll take a deeper look at CloudGuard serverless security and how it is deployed. By the end of the session, you will be able to describe how CloudGuard serverless security works to protect serverless functions, and you'll be able to perform an initial deployment and configuration. As we know by now, serverless functions are single-purpose, event-driven programmatic functions hosted on managed cloud provider platforms. This allows for greater scalability and flexibility when performing various event-driven activities in the cloud, for instance, interacting with chatbots. Even though serverless functions run without a managed server, they still execute code. This means that vulnerable code can still be susceptible to OWASP top 10 attacks. To help protect against malicious attacks targeting serverless functions, Checkpoint offers its serverless security solution as part of its workload protection suite. This solution analyzes your serverless application code before and after deployment, continuously scanning your serverless infrastructure code and runtime environment. It builds a model of normal application and function behavior by utilizing machine-based analysis and deep learning algorithms, including the automatic creation of an allow list of actions. It detects, alerts, and stops application layer attacks, such as the serverless OWASP top 10 and other anomalous activities, with CloudGuard's function self-protection, also known as FSP. In this session, we'll be discussing the deployment of the solution onto an AWS account. So, how exactly does CloudGuard serverless security protect your AWS Lambda functions? I'm glad you asked. Protection happens on several levels, which are combined to make up the allow list policy. This includes static code analysis, runtime behavioral profiling, and user-defined rules and exclusions. Let's break it down before we roll up our sleeves and start deploying. Upon the onboarding of CloudGuard serverless security, static code analysis analyzes the serverless functions code and function configuration of the AWS account. It detects configuration risks and automatically generates least privilege function permissions. It outlines recommended steps for remediation, including recommended least permissive IAM privileges in JSON format. The security admin can just copy and paste this directly into the relevant IAM role policy. Whenever a change is detected in a function's code or in its function configurations, static code analysis kicks in to analyze, detect, and offer remediating actions where necessary. Function self-protection is a lightweight Lambda layer that sits on top of the target Lambda functions to profile their usage and ultimately block malicious attempts automatically. Once FSP is deployed, the solution enters its learning period, where it examines invocations of the protected functions. It analyzes the function's behavior to define a profile of what would be defined as a normal behavior. Together with the static code analysis, an allow list is generated automatically and is stored in a dedicated S3 bucket. Enforcing the allow list can either generate alerts in case of a deviation from the allow list, or conversely, proactively and automatically block any function invocations in runtime that deviate from the allow list while reporting it to CloudGuard's backend. When an invocation of the target function occurs, it first goes through the FSP layer, analyzed against the allow list, and only if it is approved will it pass onwards down the execution path. Otherwise, it is stopped at the FSP function. Finally, to complete the picture of how an allow list policy defines what is and what isn't legitimate use of the protected serverless functions, users can define specific rules and exclusions to rules in order to ensure that certain behaviors aren't blocked. For instance, If the function needs to access a text file which was not mapped during static code analysis or during runtime behavioral profiling, an exclusion can be added to the policy. Now that we understand the mechanism behind CloudGuard serverless security, let's roll up our sleeves and start deploying. In our use case, since we're deploying to AWS, we'll be talking about an AWS-oriented deployment. The overall process consists of the following steps: onboarding a designated AWS environment into CloudGuard native, enabling serverless security, enabling runtime protection, and creating exclusions and rules. First, we need to onboard an AWS environment into CloudGuard native. CloudGuard native has two operation modes for managing AWS accounts, either read-only or full protection. Read-only allows you to monitor and examine AWS accounts within CloudGuard. Full protection, on the other hand, has a more proactive level of enforcing access and tamper protection on your AWS assets, managing security groups, and controlling direct access to your cloud assets. There are a few methods to perform onboarding, from a step-by-step process using CloudGuard and the AWS console, to automating the process using batch scripts, Terraforms, and REST API calls. In our case, we'll focus on onboarding from the CloudGuard portal. To begin, we navigate to Environments and add a new AWS environment. Now we need to select an operation mode. In our case, we'll use Full Protection. The next steps involve following the CloudGuard wizard, which instructs you how to prepare an IAM policy in the designated AWS account, granting appropriate permissions to CloudGuard to access the AWS account for information about resources. Additionally, it details how to create an IAM role in the AWS account to be used by CloudGuard to access the cloud account using the IAM permissions defined in the previous step. Let's assume we've performed these easy and straightforward steps listed in the wizard, and we've arrived to this summary screen. Based on the number of entities in the AWS environment, the process may take a few minutes to complete. This completes the onboarding process. Once fully onboarded, you can view your AWS environment and its status. Now that things are onboarded, let's enable serverless protection. To enable, we navigate to Environments and choose Enable Serverless Protection. Now we create a cross-account role. After acknowledging, we create a stack. After the stack is created, the additional permissions are granted to CloudGuard, and CloudGuard completes the process of enabling protection. When this is complete, as indicated in the CloudGuard wizard, you can see the serverless functions in the protected asset list for the account in the Protected Assets page. You can now examine the static code results and the posture findings generated from the scan. Now it's time to enable the runtime function self-protection to allow the comprehensive protection that is expected from CloudGuard. To enable, we navigate to the Serverless Functions page. We select the desired function from the list. Now we switch Auto Protect on. The profiling will commence and will complete the allow list. Since we'd like to block malicious actions that are not in the allow list, we toggle on Block on Detect once Auto Protect is done applying itself. Finally, let's define an exclusion which will manually add access in the allow list to an allowed asset, in this case, text files under the logs directory. First, we select our target function and navigate to its Rules and Exclusions tab. Then we create a new exclusion and select its target, in our case, a file. Now we enter the exclusions pattern, which is a string or a set of strings that matches against actions. If an action matches a pattern, it is added to the allow list and excluded from further inspection. In our case, since we're matching text files under the temp logs directory, We use this pattern. Finally, we select the scope this exclusion applies to, a specific function, a group of functions, or the entire set of functions in the environment. And there you have it. We've gone through how CloudGuard can protect your serverless functions, constantly analyzing and profiling the behavior of the function components, providing built-in function self-protection. And we've examined an implementation of CloudGuard serverless security in AWS. If you'd like to enhance your knowledge on implementing this solution on other platforms, such as Azure, please refer to the product documentation. Thank you for taking this session. I hope you found it useful, and I'll see you in the next one. Welcome to the session on CloudGuard AppSec. In this session, we'll take a deeper look at CloudGuard AppSec and how it is deployed. By the end of this session, you will be able to describe how CloudGuard AppSec works to protect cloud-based web applications and APIs, and you'll be able to perform an initial deployment and configuration for both application security and API protection. Web applications are programs that are accessible to users via a web browser. Organizations can use APIs that allow programmatic access to their web applications or underlying services supporting applications. As organizations shift to the cloud, they also shift the services required to build and access such applications. As we've discussed earlier in this program, assets in the cloud, such as applications and APIs, have an increased attack surface. This, together with the sheer speed which they are developed, deployed, and updated, can lead to increased compromises and vulnerabilities. Traditional rule-based web application firewalls, also known as WAFs, are simply insufficient in protecting the increasingly complex cloud-based web applications. At the core of this incompatibility is the notion that any solution requiring manual tuning of application security will never match the pace of development and deployment of applications in the cloud. This is because traditional WAFs are based on static rules, whereas the process of development and deployment of cloud-based web applications is more dynamic than ever. Adding to this dynamic is the fact that cloud-based web applications interact with potentially numerous third-party services outside of the perimeter. In effect, there are now hundreds of perimeters to secure. Finally, there's a major issue of privilege escalation in the cloud, which is not properly addressed by WAFs. Attackers that infiltrate an application will look for API keys to other applications or resources. Due to poorly configured role-based permissions, remote code execution can be much more harmful in the cloud. Here's a quick example of a vulnerable cloud-based web application which displays power meter readings. A hacker performs a SQL injection directly to the web application from the browser to zero his electricity bill regardless of his consumption. Later, he figures out that he can actually make the system work for him and pay him for consumption instead of the other way around. Using a local application he developed, he attacks an API used by the web application, reversing the charge. These kinds of attacks are relatively easy to commit for hackers who face weak protection in the form of traditional cloud-based WAFs. The better alternative to rule-based binary WAFs is CloudGuard AppSec. CloudGuard AppSec enables automated deployment that requires no rule tuning. It relies on the concept of application self-protection powered by a contextual AI engine. CloudGuard AppSec can stop application layer attacks, including OWASP Top 10, with little to no manual tuning or false positives. It can stop unauthorized API access and abuse without breaking applications and frustrating users. It can identify and stop malicious bots before they can negatively impact the customer's experience. And it can catch any HTTP-based CVEs and known vulnerabilities. AppSec relies on several mechanisms to provide its top-of-the-line protection: contextual score-based decision engine, continuous learning, Open API schema validation, bot identification, and IPS protection. Let's face it, no customer trying to access a website would be happy with being blocked due to a false positive on the website's end. This is critical to any business or service delivered via a web application. AppSec uses contextual analysis, which combines the risk analysis of multiple engines to determine if the transaction with a target application is legitimate or not. Those engines include a transaction risk engine, which breaks the transaction into small elements called attack indicators, which are then examined by a dedicated machine learning algorithm to make the decision to block or allow. Additionally, AppSec uses a user behavior risk engine, which analyzes all of the requests made from a specific user, looking into malicious intent in prior user requests. You can take this one step further by creating an allow list of trusted users, which accelerates the application learning. Furthermore, the crowd behavior risk engine maps a site based on how all users interact with it. If a critical mass of users uses a website a certain way, the probability of a request being a specific attack is lower. Finally, the content risk engine learns what content is typical for a specific field in a specific application, providing a deeper analysis of the content itself and the patterns that are expected in each field. The final score reached by the decision engine is either to allow the transaction through to the application or to block it, this while dramatically minimizing false positive decisions. Before the engines kick into action, the system begins in learn detect mode. In only a short period of time, it completes its learning and the user can choose to switch it to prevent mode. Behind the scenes, the system gathers raw data on the transaction sources, their HTTP methods, the type of HTTP requests, and their headers. This information is all parsed and fed into the aforementioned engines for analysis. When the system completes its learning, the user can choose to switch it to prevent mode. This process of gathering data, parsing it, and feeding it to the engines is performed on a continuous basis. A user can assist the learning process and shorten the learning curve by responding to tuning suggestions. For example, this user assistance is called supervised learning. AppSec narrows the scope of API attacks by allowing API schema validation. Users can upload their schema, which describes the API functionality of the server. AppSec then makes sure to enforce this schema by ensuring that no one can infiltrate applications via API fields and values that are not explicitly allowed in the schema. The use of bots for automated attacks against login pages is a regular practice among threat actors. CloudGuard AppSec utilizes client-side behavioral analysis to distinguish between human behavior and bot behavior. Once a client connects to a server, it performs a GET operation. It receives the page from the server, including a JavaScript developed by Checkpoint that is injected to the browser of the client. The script collects behavioral information from the client. When the client performs a POST operation to the server, it will include the decision of the script, which defines if the request originated from a bot or from a human. Finally, the IPS protection offered by CloudGuard AppSec is complementary to the protections already discussed. AppSec IPS protection, which is based on Checkpoint's award-winning Gateway IPS protection, catches any known vulnerabilities, preventing known malicious CVEs by looking for network signatures in HTTP requests. Now that we know what CloudGuard AppSec can do, let's focus on its possible architectures and deployment considerations. There are currently 3 available types of deployment, which can accommodate various implementation scenarios. It can be deployed either via the CloudGuard AppSec Gateway as an embedded nano agent on top of any Linux machine running an Nginx web server or an Nginx reverse proxy, or as a nano agent Docker container. Let's elaborate. When implementing AppSec via the CloudGuard AppSec Gateway, we have a CloudGuard AppSec Gateway virtual machine deployed in front of the web server to be protected. It runs on a Checkpoint Gaia operating system as a secure OS with an Nginx reverse proxy and an AppSec Nano agent, which is the core of the solution. In this deployment scenario, NGINX is managed from the Infinity portal by the user. AppSec can also be deployed as an embedded Nano agent on top of any Linux machine running an NGINX web server or an NGINX reverse proxy. The Nano agent attaches to the NGINX as a standard plugin and provides CloudGuard's AppSec features. This type of deployment can take shape in two ways: either as an NGINX web server where both protected web app and the Nano agent reside on the web server, or as an NGINX reverse proxy where the Nano agent resides on NGINX. In this case, the NGINX reverse proxy is set up in front of the protected web app. Alternatively, AppSec can be deployed as a Nano agent Docker container, either on top of an NGINX Ingress controller within a Kubernetes Ingress pod, or on top of an NGINX reverse proxy Docker container. These solutions are also deployed in front of the web application to be protected. For the sake of simplicity, we'll focus this session on deploying AppSec as an embedded Nano agent on top of a Linux machine running an NGINX reverse proxy. Before we go over the deployment process, let's break down the elements that enable the AppSec solution. First, we have the what. What are we protecting? This is referred to as assets. An asset maps to URLs of websites. Then we have the how. How is this protection being applied? This is based on the selected deployment profile, which we'll elaborate on in a minute. The deployment profile includes a built-in security policy which is applied on the protected assets and defines the expected behavior for a set of AppSec security engines. Finally, we have the by whom. Who is in charge of enforcing the policy? The answer is AppSec's Nano agents. These Nano agents are services which implement security monitoring and enforcement based on the defined policy and the assets they're attached to. Now, let's define the high-level deployment process of our chosen scenario, providing application security and API protection using an embedded Nano agent on top of a Linux machine running an NGINX reverse proxy. First, we define the AppSec policy. Then we deploy the Nano agent. And finally, we can create exceptions and additional definitions on the Infinity portal's end to accommodate any special requirements that go beyond the default settings. Let's break it down. Defining the AppSec policy includes defining the assets we wish to protect and the type of agent deployment we wish to implement. Policy practices will be automatically populated with Checkpoint's best practice defaults at the end of this process. This policy will be enforced by the Nano agents. In our use case, since we would also like to protect web APIs on top of applications, we will need to upload an API schema to enforce the API calls being sent to the application. Next, we deploy the Nano agent. In this step, we install a Nano egg on the target Linux NGINX machine. The Nano egg is a binary that creates trust between the protected asset and the Infinity platform in the cloud. The Nano egg then deploys the relevant Nano agent services based on the policy and the environment on which it is installed. Finally, we can create exceptions and additional definitions in the Infinity portal to accommodate any special requirements that go beyond the default settings. All right, it's time to deploy. It is assumed that you already have a Checkpoint Infinity portal account set up at portal.checkpoint.com and that you have an NGINX reverse proxy set up as the target Linux machine, as this is beyond the scope of this session. Let's first start with the solution's front end. We log into the Infinity portal and open CloudGuard Application Security. Next, let's add an asset of type Web Application. For ease of use, we can start this from the Getting Started screen. After our Web Application asset is set up, we will do the same for Web API protection. In the wizard, we define our target for protection. We name it, define its zone if it is part of a group of assets, define whether it's in the stage of staging or production, and finally in this step, we add the front-facing URL for the web application. Now we choose the type of practice to apply to our target. This represents the type of policy to enforce. In order to train the engines to detect legitimate traffic versus malicious traffic, it's best practice to keep it on Learn Detect until learning has progressed sufficiently to recommend the move to prevention. The amount of time for this process varies by the number of requests sent and whether trusted users have been defined, but more on this later on in this session. As discussed earlier in this session, part of the learning process involves profiling user behavior. For that to happen, AppSec needs to distinguish between users. One way of doing this is by their differing IP addresses. To ensure their original IPs are forwarded to AppSec, instead of any IP address of an intermediary machine along the way, such as a proxy, we choose this option. We can also help the engine by identifying ahead of time source IPs that are unlikely to be malicious. This helps accelerate AppSec's learning phase. Now we define a deployment profile. We can either choose a profile we've previously created or create a new one. Since in this case it is a first-time configuration, we'll opt for creating a new nanoagent profile to be deployed according to our selected implementation. That is, a nanoagent within an Nginx reverse proxy set up as the target Linux machine. In the wizard summary step, we can publish the application security policy and enforce it. Publish saves changes to the database, and enforce means the policy changes are ready to be picked up by its target, similar to install policy on a gateway. Our web application asset to be protected is now set up in the front end. Now, we proceed to deploy the nanoagent. First, we navigate to our profile in question. This will be our source for establishing the trust between the nanoegg installed on the target asset and the Infinity platform. Now, we open an SSH connection with a target machine. Once established, we can copy the commands from our profile in the front end to establish the connection with the Infinity Portal backend. This will be preceded by the fetching of the nanoegg, its installation, and its automatic download and installation of the nanoagent components from the backend, while also fetching the policy. This is all done while using the system-generated reusable token. At the end of the process, a success message should appear in the command line window. To check that the agent is up and running, we run the command cpnano-s. A message will also appear in the portal indicating that the agent has connected successfully. This completes the nanoagent deployment, which means application security for our target asset is active. Now it's time to set up API protection. As mentioned, AppSec provides open API schema validation, ensuring that no one can infiltrate applications via APIs and fields that are not explicitly allowed in the schema. We start by adding an asset of type Web API. We make our way through the wizard in a similar fashion to what we previously did for the web application security. We can use the previously created agent profile or create a new one. In our case, let's use the existing one. Once done, it's time to upload the Open API schema. Under the Threat Prevention tab within our asset, we hit the Upload button and select our schema. Finally, we publish and enforce. Now, let's briefly explore various nooks and crannies of the system where we can find some interesting insights. Naturally, navigating to the various sections here will provide us with information on the various entities we've set up. Under Agents, we can view the list of nanoagents that are configured to work with our deployments. As we can see, the status of this agent is connected. Beyond that, we can access the AppSec Monitor, which provides us with rich data concerning incidents handled by AppSec, including attack sources, the timeline of attacks, and the assets that have been attacked. Events displays a list of incidents. In case you'd like to customize your AppSec policy, you have various ways to do so. For instance, adding an exception to the policy which blocks requests from a certain source IP. Based on parameters defined here, when there is a match, the agent will operate according to what it's instructed to do here, overriding any AppSec engine-defined criteria. You can further narrow down or broaden the scope of exceptions by adding behaviors. In terms of best practices, we've already mentioned the learning period, which is the period during which the AppSec engines gather and analyze data to build adequate profiles. After this period is over, the system provides us with a recommendation to switch to prevention. Following that recommendation, we can go ahead to the Assets Threat Prevention tab and switch the mode to Prevent. For additional best practices, please refer to the AppSec Best Practices section in the Infinity Next Administration Guide. And there you have it. We've gone through how CloudGuard AppSec can protect your cloud web applications and APIs, utilizing sophisticated AI-based engines which learn to detect normal versus anomalous behavior, constantly analyzing and profiling the behavior of incoming traffic to the protected assets, providing in essence an application self-protection, which requires no manual tuning. We've detailed a deployment scenario of an embedded nano agent within an Nginx reverse proxy running on a Linux machine. We also mentioned various other forms of deployment depending on the environments you operate in and your protection needs. If you'd like to enhance your knowledge on implementing the solution, please refer to the Infinity Next Administration Guide. Thank you for taking this session. I hope you enjoyed it, and I'll see you in the next one.
Welcome to this program summary session. In this session, we'll briefly summarize what we've seen and learned in this program, as well as provide some references to resources to further enhance your knowledge.
In this program, we presented the major threats and vulnerabilities that are amplified when protecting workloads and web applications in the cloud. We went through some common solutions addressing these security challenges and established that in many cases they are insufficient. We then presented Checkpoint's dedicated solutions for protecting cloud workloads and web applications that fall under the CloudGuard umbrella. We discussed the major advantages of protecting cloud assets via CloudGuard Workload Protection and CloudGuard AppSec, and how they provide robust protection using advanced technologies such as machine learning and AI to provide the top-of-the-line protection while demanding little maintenance and tuning. We learned how CloudGuard Shift Left can help us complement runtime security by shifting security to the left and into the CI/CD pipeline to preempt any vulnerabilities and misconfigurations during the development process in the cloud. And finally, we walked through some basic deployment scenarios involving CloudGuard's container, serverless, shift left, and application security solutions. To further enhance your knowledge, please refer to the respective solution documentation. Additionally, if you're not already a member of the rich and dynamic community of Checkmates, where you can find the latest tips, tricks, and deep dives, you should definitely check it out.
And with that, our program has come to its end. I hope you found it both useful and enjoyable. Thank you for participating, and good luck.
Hello and welcome to Quantum Spark Jumpstart Introduction. This is one of my favorite products, Quantum Spark, and this series is a Jumpstart program, meaning you have this wonderful product at your hands and you want to know how to get started with this product, how to efficiently protect your organization with this solution. Well, you've come to the right place, because by the end of this training, you'll be able to deploy Quantum Spark within your organization and start to efficiently protect your organization. We'll also perform some administrative tasks within Quantum Spark, for example, VPN, management options, meaning how do you want to manage your device, locally from the box, from a different box, or maybe from the cloud, how to set up wireless network, how to get updates, how to configure and modify your security policy, how to run upgrades, troubleshooting, and of course, monitoring. So we're going to have a lot of fun together. So Quantum Spark is an appliance suitable for the small and medium business. Because if you have a bigger organization, you might go with one of our bigger appliances. It depends, for example, on the throughput and the blades you want to enable. So Quantum Spark is right here. And if we will zoom in on the small to medium businesses appliances, we can see these beautiful appliances. For example, the 1535, which can support up to 440 megabit per second and supports Wi-Fi 6, and up to the 1595, which can support 900 megabit per second, Wi-Fi 6, and a 5G network. Amazing. Quantum Spark, what a solution. I really like the definition of Spark. It's an enterprise-grade security for small to medium-sized businesses. All-inclusive security, next-generation threat prevention, application control and URL filtering, IPS, antivirus, anti-bot, anti-spam, sandblast, threat emulation, which you might know as sandboxing. It provides the same level of security as a quantum gateway. It's integrated with Wi-Fi 6, which is new and exciting, XDSL, and cellular traffic with the latest 5G network. It is easy to deploy and manage, and it's a real all-in-one solution. You have on-the-go real-time security alerts and remediation using the Watchtower mobile app, which will have a great video on it. You get simple and insightful reporting. And look at this beautiful throughput, 2.8 gigabits per second firewall, 900 megabits per second of threat prevention, and perhaps the crown jewel, Quantum SD-WAN support, so you get optimal app performance. So during the demos, I'm going to use this topology. This is my home network, so I have my home router at the end. It's an ISP router, it's a dumb router, so every traffic it gets, it just forwards it back to its destination. During the demos, I'm going to use a real live topology. It's going to be connected to my home router at home. It's a dumb ISP router, meaning no firewall rules or special configuration, just your out-of-the-box ISP router. The network it's managing is 192.168.1.0/24. It's a Class C network. On this network, I have my own PC, which I'm going to use to manage it all. That's going to be my admin machine. I have a PBX server, which will allow me to conduct voice over IP calls within my network. I have a VoIP phone on my network as well. I have an Active Directory server running Windows Server. So I'm going to use it to create users and then integrate it with my Quantum Spark, which is right here. I have a Quantum Spark device, and it also hosts its own private and protected network behind it with one PC. The structure of the course is going to be very simple. I'm going to start with a brief introduction like this one. This one is some sort of introduction as well, but it's going to be an introduction per the topic we'll discuss, followed by a demonstration, so you'll know exactly how to get started with your appliance. So it's going to be cool, and most importantly, it's going to be real, because I have a real device. I'm going to install it. No smoke and mirrors. You're going to get the real appliance out of the box and installed to give you the best security, because you deserve the best security. So without any further ado, or actually you may pause the video, because you can pause the video, but anyway, let's get started. Installation. By the end of this training, you'll be able to install the operating system as a VNF and run the first time wizard. If you want to play with Quantum Spark, you can either use it as an appliance, a physical device that's right in front of you and you can actually hear it and touch it and smell it, if that's what you like, or you can use it as a VNF, meaning as a virtual machine. The operating system is going to be Gaia embedded. It's slightly different than the regular Gaia you all know and love. If you're using an appliance, then the operating system is pre-installed, meaning you plug it in, the operating system is already running. But if you're using a VNF, you'll need to install the Gaia embedded yourself, which is actually really easy, so you don't need to worry about it. First time wizard is something you'll need to do on both appliance and VNF. This is the product installation, so you'll select if you want to manage this device directly or maybe from a dedicated management server. You'll set up the credentials and access to the device. You'll enable the blades you want to have. Networking settings, for example, if you want to get an IP using a DHCP, or maybe you're going to add it statically, and so on. Set up zero touch, or actually that's the time to use zero touch if you've configured that. And also, if you have internet connection, you're going to obtain the license automatically. If not, you can do it offline or just set it up later as well. So all of these settings will be configured during the first time wizard. During the demo, we'll do two things. One, we'll install the VNF. If you want to use the VNF, you need to either have the ISO or maybe the OVF file if you're using VM Workstation, and some sort of virtualization software. In this case, I'm going to use VMware Workstation. For the first time wizard, you'll need to be familiar with the network topology you're using, so you'll know where to plug it in, which IP address to use, and so on. You'll need a browser, and you will need an Ethernet cable. So this is my topology. I'm going to connect my admin machine directly to the LAN 1 network, so I can go ahead and get an IP address and start managing the device. And actually in this demo, I'm going to connect my appliance using a SIM card to the internet using the cellular data package and not directly to my home router, just for this demo. To install Quantum Spark as a VNF, I'm going to SK 168204. And down here, I can see the available downloads, so either as OVF files or as ISO. And I've already downloaded this file. I'm going to download it again. So you get a TGZ file, I've extracted it. And now from VMware Workstation, in my case, I'm going to open a virtual machine. I'm going to browse to the location of the OVF file that I've extracted. Give it a name. Location is fine. Import. I'm going to edit the virtual machine settings. By default, I have two network interfaces. I'm going to modify them and place them on a different VMnet. And I'm going to add a third adapter. Now, I still don't know which interface is which, meaning I don't know if this is the WAN adapter, if this is the DMZ adapter, I don't know. So I'll turn it on and then we'll know together. Press OK. And power on. In this specific VNF, I was using an OVF, so the operating system was already installed. And now I can just log in with admin. Default password is admin again. And now I have access to Clish and I can go ahead and do whatever it is that I want. I can change the adapter, IP address, I can change the host name, whatever it is I want to do. Now, I do want to know the interface's assignment. So I'm going to set up expert password. I'm going to enter expert mode and I'm going to display the MAC addresses just so I can know which interface is which. Okay, so now I can see DMZ, LAN 1, and WAN, and I can see the MAC addresses. So what I'm going to do now, I'm going to access the virtual machine settings. And I can see the MAC address of CC is network adapter 1. So network adapter 1 is DMZ. So I'm going to place it on VMnet 3. Second adapter is D6. D6 is the LAN 1, so I'm going to assign it to, I don't know, VMnet 1. And the last one, E0, that's the WAN adapter. So in my case, I'm going to modify this to NAT. And that's it, I've successfully installed a VNF. To run the first time wizard, I need browser access to the appliance. So I'm going to take my admin machine, connect an Ethernet cable to the port. Now in this case, the appliance is running as a DHCP server, so I'm going to obtain an IP address automatically, and I'll know the address of the device is something something something.1, and if not, I'll show you how to check it. And then you'll need to open up a browser session, https:// the IP address of the appliance, which you'll need to figure out. But it's not going to use the regular port for HTTPS, it's going to use port 4434. Okay, so let's see it. So here I have all of my network adapters. This is the adapter that's currently connected to the appliance. So I'm going to the status, details. So the IP address that I'm getting is 192.168.1.224. My default gateway is 1.1. So that's the IP of my Quantum Spark. I'm going to open up a browser, type in the IP address 192.168.1.1:4434 and press enter. So the connection is not private because the appliance is presenting me with a certificate that is self-signed, so I'm not aware of that certificate. I'm going to go ahead and approve. And this is the first time wizard. Now, currently I don't have zero touch, so I'm not going to be able to use that. I'm going to set up next the administrator name and password. So I'm going to stay with admin, but I will change the password. I don't want password complexity, so I'm going to leave that unchecked. Help us improve. Yeah, sure, why not? Press next. Date and time. It's okay. I'm not using a network time protocol, so I'm going to leave that off. Press next. My appliance name, I'm going to change it. I don't have a domain. I'm going to manage my device locally, and we'll elaborate on it on a later video. But basically it means I'm going to manage the device and policy by using the local web application. Unlike if you're going to use central management, it means you have a dedicated management server to manage this box. But I'm going to stay with local management. How would you like to obtain internet access? In this case, my internet access is not over a DHCP or an Ethernet cable. It's actually using cellular. So I have my SIM card in. I'm going to press connect. And of course, if you want, you can always configure internet connection later. I'm connected. Here's my IP address. Press next. Now it asks me, how do I want to configure the LAN network? So I'm going to configure the LAN network to be actually .2, like so. The subnet mask is fine. The DHCP is being calculated automatically. I don't have an exclusion range. Press next. Now this setting right here is very interesting. How would you like those 8 ports to behave? Meaning, if I enable this, those 8 ports are acting as a switch, meaning they're all connected to the same LAN network. However, if I'll uncheck it, I'm currently only configuring port 1. So if I'll have another computer connected to port 2, that's going to be an entirely different network. So you can go ahead and modify this now or later. In my case, I'm going to set it up as a single network. Press next. In this window, it asks me if I want to set up the wireless network. Currently, I don't want that. I'll configure the wireless network later. How do you want the administrator to access the device? I'm going to allow the administrator to access the device from any connection and from any IP address. Of course, if you want better security, you can go ahead and modify it, but in this lab, I'm going to leave it as following. It's going to register my appliance. I do have internet connectivity, so this should work, and I have obtained my license. Which blades I want on, I'll use all of them. And that's it. Here's a summary. I'm going to go ahead and approve it. I'm done. I have my appliance running and ready. Web UI Overview. By the end of this training, you'll be able to log in to the Web UI and describe the functionality of each tab. The Web UI is a web application, so you'll need a browser if you want to use it properly. And basically it means that you're going to use a PC to connect over HTTPS to your Quantum Spark. And notice that by default, we don't use the classic port for HTTPS, but port 4434, just because it's more secure this way. From this Web UI, you'll be able to manage the device itself and configure the security policy. So unlike the classic architecture where you use the Gaia Web UI only to manage Gaia as an operating system, when you're using Quantum Spark, you're using the Web UI to do both device configuration and security policy. These are the main tabs from within the Web UI. So you have in home mainly overviews, device. This is mainly device configuration like IP addresses, network addresses, upgrades, and so on. Things related to the access policy, the threat prevention policy, VPN connections, if it's site to site or from a client or from an application, user and objects, and finally logs and monitoring. If you're ever feeling lost, from the home page under overview you have the sitemap. In the sitemap you have all the different links simply laid out, so you can easily find whatever it is you want to do. And of course you can always just go to the previous page and search for the option you want. But some people like this display, so it's here as well if you prefer it. For this demonstration, you will need connectivity to your Quantum Spark, and you'll need to know the credentials of the appliance so you'll be able to log in and do your stuff. Here's my appliance, so I'm currently at the home page. So here under system, I see the system information, my version, the device name, the MAC address, my uptime. Network, I can see that I do have the internet connected. I'm currently connected over cellular. This is my IP address. Wireless networks are turned off. In this case, I have dual channels. The Watchtower mobile app, currently I still haven't set it up, but I can set it up from here. Network activity here below. Notifications. So for example, earlier today, I've set up a test. So I see the malicious file was indeed blocked. Security dashboard. I can see the different blades. I can see that they're enabled, and I can go ahead and modify them from here. Security management. So we'll talk about this in a different lesson, but currently my device is locally managed, meaning I'm managing everything straight from this box, from the Web UI, but I can go ahead and change central, and then it means I'll manage this box from a security management server. Here you can configure a cloud service provider that can handle your security policy and supply a variety of services. Yeah, I just read it from here. But in other words, for example, if you're using Spark management, you can set it up from here. And we'll do this in a later video. License. So you can see the services that I'm using, my MAC address, my registration key. Currently was activated automatically. So for example, a few months ago, I had to modify my license. So after I've modified my license, I've just clicked reactivate, and it pulled information in again, and it got the update that I have a different license. Or of course, you can do it offline as well. This is the sitemap that we've discussed earlier. The monitoring tab, so I can see the notifications, the active devices that are currently connected to my device, monitoring information. Okay, so I can see all of the different applications that were being used, so this is quite nice. I can see Checkpoint IPsec. It's because my computer is connected over a VPN, so I have that traffic. Different reports. This is a really nice report that you can generate. Tools, we'll talk about this in a later video, but this is troubleshooting tools to get insights or to run diagnostic tools. And support information. Moving on to device. So, as we mentioned, this is where you manage the device from. So you have network settings, like for example, if you want to set up the wireless network, set up the local network. And we've discussed this in a previous video where you can go ahead and configure how the device will behave. Will it act as one big switch or as separate LANs? So you can customize it from here as well. System operations, you can go ahead and run upgrades, set up administrators, the administrator access, and you have lots of information here. Advanced routing, this is actually really cool. Certificates, high availability settings, and so on. Access policy, everything related to your security policy, but we'll discuss this in a later video. Threat prevention, everything related to threat prevention. For example, IPS, antivirus, anti-bot, threat emulation, they're all enabled and up to date, which is important. And I can see the policy that's being used. VPN. I currently don't have any VPN sites, but in the future, we'll set it up straight from here. Users and objects. So in a later video, we'll connect our Quantum Spark to Active Directory. So we'll be able to pull information about the organization from Active Directory. And finally, logs and monitor, which gives you great insights about what's going on within your organization.
Thank you for watching, and I'll see you in the next video.
Policy out-of-the-box state. By the end of this training, you'll be able to describe the out-of-the-box state of Quantum Spark and review current policies. So right after First-Time Wizard, you are protected. Out of the box, you've completed First-Time Wizard, you're already protected. Because if you'll take a look at the policy, you'll see that by default, you have the standard policy. Now, unlike the classic firewall architecture when you're using Quantum Firewall or Quantum Gateway, there, the default policy is any drop. But this is an SMB device. It's Quantum Spark. So it's ready to protect you. Okay? So the default policy is to allow traffic to the internet on all services, allow traffic between internal networks and trusted wireless networks, block incoming traffic, and as for application control, it's going to block security risk categories. So right out of the box, you'll be able to go to the internet, you'll be able to access other internal networks in your organization, but any random incoming traffic, and we're not talking about replies to your traffic, this is just someone trying to access your internal network, that's going to be dropped. Let's have a look. So if you want to have a look yourself, make sure you have connectivity to Quantum Spark and that you have the right credentials for the appliance. So here I am on my appliance. You can see it's the Quantum Spark 1590 appliance. And here under Firewall Policy, I can see indeed everything we saw on the slide. And if I'll go to Policy, I can see the actual policy in a well-known and lovable format and a rule base. So I can see outgoing access. I have any source to internet destination, and if the application or service is undesired applications, and I can double tap, and I can see which are those unwanted or undesired applications. I can see that it will be blocked with a log. Next, I have the any to the internet on any service except with no log. And then I'm going to have the incoming. If it's someone from within the LAN networks to any destination on any service, yes, they can do whatever they want. Anything else, that's the classic cleanup rule. So these rules are auto-generated. It's similar to the auto-generated rules you have with NAT when you use classic quantum. Okay, so it's good as is, but if you want, you can always go ahead and add a new rule and customize it to look however you want your security policy to behave. You can go ahead and modify and add additional rules.
Thank you for watching, and I'll see you in the next video.
Policy customization. By the end of this training, you'll be able to modify firewall and application control policy and create a manual rule. The basics of a policy is any traffic can be categorized into its own source, destination, and service. So for example, I can say any traffic coming from any destination can be my DMZ, for example. Service can be FTP. So whenever traffic comes in and we can match it to a rule with these categories, we have an action. The action can be drop or accept. As we saw in a previous video, you already have default rules to protect your organization. However, in this video, we'll see how to customize it and add more rules to your policy. In order to demonstrate this, you'll need access to your Quantum Spark, you'll need to have the right credentials, and you'll need to know what's the organization's network and security needs. Do you want to block that website? Do you want to allow that website? And so on. Here I am from Access Policy. I'm going to enable block file sharing applications. And let's press Apply. I'm now connected to a new client, which is protected by a Quantum Spark, meaning all of my traffic here goes through Quantum Spark. Let's try access Dropbox. The site can't be reached. Now let's try to access WeTransfer. Blocked as well. So currently, this rule that I've enabled blocks Dropbox as well, because it's a file sharing application. I'm going to Policy. Let's refresh this page. So now if I'll go to Undesired Applications, I have file sharing applications as well. Now, I want to override it. So yes, I want to block file sharing application, but Dropbox is a website that I do want to use. I do want to allow that website. So I'll need to override this. I'm going to create a manual rule on top. Source, let's have it specific from our LAN networks. Destination is internet. An application, let's search for Dropbox. Accept, keep a log, no need to modify any of that, press apply. Okay, now let's go back to the Windows client machine. Refresh. And now it works, because now I've added a manual rule to allow that specific traffic. In my case, it was Dropbox, but you can go ahead and add whatever traffic you want to allow within your organization. Thank you for watching. Policy SmartXL. By the end of this training, you'll be able to enable SmartXL and customize SmartXL. Have a look at this list. We have Apple, Checkpoint services, Google services, Microsoft updates, media streaming services, Amazon, Disney Plus, and Netflix. Now, can you think of what ties them all together? They're all at low risk because we're talking about traffic from Apple, from streaming services, from Google, from Microsoft. So they are currently low risk. SmartXL is a beautiful feature that we have that will bypass these low risk services and will give you better performance. So in other words, it means you can bypass the network inspection for these specific objects. Services such as those corporate services, media streaming services, and so on. Assets, so devices such as computer, audio player, or alarm can be bypassed. This improves connectivity and optimizes the load on the Quantum Spark security gateway. To go ahead and utilize this tool yourself, make sure you have connectivity to Quantum Spark, make sure you have the right credentials, and the organization's network and security needs. Because I assume your organization, for example, uses web conferencing applications. So in that case, you would like to have that service bypassed. However, in some organizations, streaming is forbidden from within the corporate network. So you don't want to bypass, you just want to block that, right? To enable SmartXL, simply go to Access Policy, SmartXL, and currently it's on. You can just tap it, set it to off, or turn it on again. If you want to customize SmartXL, you can click the All Services selected and select exactly what services you want to accelerate or not. For example, I can go ahead and remove TikTok or Skype or WebEx or Zoom and whatever you like. So very easy to turn it on, very easy to customize it. And if you want to see the assets, this is here under Policy Bypass. You can just turn it on. And then again, it can bypass specific assets within your network, like alarm clocks, audio players, and so on.
Thank you for watching, and I'll see you in the next video.
Voice over IP, or VoIP, is a key element in an organization of any size. No need for the classic PSTN infrastructure. All you need is TCP/IP. And since in between the networks we have a security gateway, we will need to allow this traffic in the policy. In earlier version of Quantum Spark, you had to manually add the rules and create a network object for the source and the destination. And it was a long and painful procedure. Although we have a very detailed SK about it, it was just very detailed. Very detailed. Worry not, my friends. In version R80.20, we have released a new VoIP wizard, which will guide you through creating the right rules based on your topology. Simple and easy to use. First, let's review our topology. We have our Quantum Spark connected to the WAN network, in this case, the 192.168.1.0, which is my physical address at home, and the Quantum Spark WAN adapter is connected to this network. We have the 192.168.100.0 network. It's a wired network protected by Quantum Spark. And since it's the 21st century, we have a wireless network as well, secured by our appliance. We have phones on all three networks. The PBX server is in the WAN network. As you know, Quantum Spark offers out-of-the-box security. So if we'll check the current policy, it will only have these auto-generated rules, and incoming traffic to the Quantum Spark device will be dropped. Here I have a soft phone app, and I'm initiating a call to a client which is behind the Quantum Spark box. And as you can see and hear, the call could not be completed.
The person at extension 300 is unavailable. Please leave your message after the tone. When done, hang up or press the pound key.
Let's select VoIP from the menu on the left. Turn it on. In my case, the SIP server is off-premise, as it's on our WAN. I will create a new object to represent the IP of the PBX server. Next, I will configure the devices which are on-premise. I will create network objects for every network I have and add them to the list. That's it! You can see the cool topology that was generated on the right, illustrating our topology. It's much nicer than the one I created manually before. I call dibs! If you scroll down, you will see the properties of SIP services and the ports they use. Make sure your clients are configured to use port 5060 as the source port as well. Now, let's see if it all works. I have my soft phone app on the left, and let's try to make a call. Looks like we have an incoming call from George. We did it.
Thank you for watching, and I'll see you in the next video.
Management options, local management. By the end of this training, you'll be able to configure Quantum Spark as a locally managed device. When you want to manage your Quantum Spark appliance, there are three main options. Locally managed, when you use the same single web applications to manage both the security policy and the device configuration. Second option is centrally managed. This is, you might say, the classic method in Checkpoint, where you have a security management server on site or on cloud, which manages all the gateways within the organization. So then you'll use SmartConsole to manage your security policy and the web UI to manage the device itself. The third option is the Spark management, which you'll use if you are using a much larger scale. So you have dozens or hundreds of Quantum Spark gateways and you want to manage them all. So it's a beautiful feature. However, in this video, we'll show you how to set up the local managed Quantum Spark. The local managed device, you only need the web UI. So it's a single pane to do everything, manage the device and the security policy. So if you have a single device, this is a great option for you. And here I have a VNF, and I'm going to run through the first time wizard to show you how you can select the locally managed option. Hitting next. For password, I'm just going to go ahead and type something. Time zone is okay. I'm just going to use the auto-generated name here. And here we go. Local management. And I can go ahead and use that option to locally manage my device. So I'm just going to go ahead and press next. And by the end of First Time Wizard, my device will be locally managed. So it's going to look like this, where you have one web application to manage both the device and the security policy.
Thank you for watching, and I'll see you in the next video.
Management Options, Central Management. By the end of this training, you'll be able to configure Quantum Spark as a centrally managed device. In a previous video, we've discussed the three options to manage your Quantum Spark. It can either be locally managed, which means you'll use the local web application to manage your device. You can either use the central managed option, which we'll use right now, which means you'll use a dedicated management server to manage your appliance, or through Spark Management. In this specific video, we'll walk you through using centrally managed device. If you're using the central managed device, it means the web UI is only going to be useful for OS configuration, managing IP addresses and stuff like that. But the security policy aspect, that will be configured through SmartConsole. Why would you use this? Because it's scalable. You have multiple gateways, multiple locations, you want to manage it from a single place. That's why you'll use centrally managed device. So what I'm going to do right now is I'm going to set up a management server which will manage this box right here. Since my device is after First Time Wizard and I don't want to go ahead and reset it, I'll need to adjust it from the web UI. So I'm going to Home, Security Management, select Central, and hit Apply. And the first thing you can see is how everything here changed. You no longer see everything related to the security policy because you will now do that from SmartConsole. So just like any security gateway, you now need to go ahead and set up a SIG password. So I'm going to set up. Now I don't have security management service, but this is something you can definitely do. In my case, I have a classic open server security management server. Press next. I'll connect to the management server later. Press finish. Now I have SIG ready. Now I'll need to go to SmartConsole, set up a new gateway, classic, give it a name, the IP address, under hardware, I'm going to select my appliance, communication, set up the password, okay, trust established, press OK. I have the proper topology, press OK. Let me go ahead and install the policy. And that's it, succeeded. So I now have a security management server managing a classic open server security gateway and a 1590 appliance, which is my very own Quantum Spark device. Thank you for watching. Management Options, Spark Management. By the end of this training, you'll be able to connect Quantum Spark to Quantum Management Portal. As we discussed in previous videos, there are three ways to manage your Quantum Spark. The first option is the locally managed, where you use the single web application to manage both the security policy and the device itself. Next, we have the centrally managed option, where you need a dedicated security management server. Can be open server, can be on cloud, can be on an appliance, but it's more scalable. And if you want it to be even more scalable, you would use the Spark management option. So Quantum Spark Management is great because it's a single console to manage thousands of customers. It's part of Checkpoint's Infinity Portal cloud management solution, provides unified management, monitoring, and analysis, granular role-based administration, and as you can see, provide extensive logging, reporting, simplified group-based security provisioning using plans. So the idea is you set up a plan, you modify the plan with the security blades, the firewall policies, and so on, and you assign a gateway to a plan. As easy as that. So I've connected to the Infinity Portal using my account, and as you can see at the moment, I have 0 gateways and a single plan. If I click on the plans, I have the initial plan. You can see the blades that are enabled. I'm going to go ahead and modify it. Going to security software blades, firewall access policy. And just a few minutes ago, I've added a manual rule to allow WeTransfer. And I've saved that already. Now I'm going to gateways, and I'm going to add a gateway. So this is going to be a small office appliance. The name is going to be Spark 1. Registration key, I'll use that. Finish. Okay, so now I have prepared everything I need for the gateway. Now I'll need to go to the gateway itself and introduce myself to Quantum Spark Management. I'm now copying the activation key. Now I'm going to Home, Cloud Services, Configure, and it's just a single string. You just paste it, press apply. Let's hit details. I can see the status if I want to. And we'll just wait for a few minutes. I'm now connected. I can do details to get that information. Let me show you a cool thing. In a previous video, I have manually added a rule to allow Dropbox on the appliance. From the Quantum Spark Management, I've modified the plan to allow WeTransfer. If I'll go to Access Policy, here we go. I can see the Dropbox rule and the WeTransfer rule. And you can see that this rule takes preference as well. So that's really cool. And we have now successfully added Quantum Spark to be managed via Quantum Spark Management. Thank you for watching. User Management Active Directory. By the end of this training, you'll be able to add a new Active Directory domain to Quantum Spark. User management is essential for when you want to use either user awareness, meaning you don't want to see just an IP address, but you want to know, hey, that's Bob. And for when you want to use VPN, for example, it's very common to set up users so I can authenticate by my username when I'm connected remotely. You can create those users locally on the appliance, or you can sync and get them through Active Directory. So in the next demo, I'm going to connect my Active Directory server with my Spark appliance. let's see how easy that is. If you would like to run this demo yourself, you'll need to have the information about your domain controller, the IP address, and credentials. From the Infinity portal, I'm going to Users and Objects, Active Directory Queries, Configure, my domain name. I've added my domain name, my IP address, username, and password, and if I'll hit Discover, it worked. So it managed to pull the distinguished name from the domain. Hit Apply. And for example, if I'll go to VPN, Remote Access User, I can go to Add, Active Directory Group, and I can see the group I've created on my Active Directory domain server. I can just add them. So in this case, for VPN, any user that's part of this group will be able to set up, in this case, a VPN tunnel.
Thank you for watching, and I'll see you in the next video. Threat Prevention Out-of-the-Box State. By the end of this training, you'll be able to evaluate the out-of-the-box state of the device. Once you have completed the first-time wizard, all of the threat prevention blades are enabled. Updates are pending, so after you've ran the first-time wizard and you have established internet connectivity, you'll be able to get the latest updates. SSL inspection is currently disabled, but the device is using HTTPS categorization instead. I have now switched over to my Quantum Spark VNF appliance, meaning this is not my real physical appliance, it's a virtual one, because I wanted a fresh install without any of the updates. So if I'll go to Threat Prevention, I can see that in terms of the blades, IPS, antivirus, antibot, and Threat Prevention are enabled, and I have updates pending. So all of the updates are scheduled automatically. I can click on one of those. I can see the schedule updates. This IPS is up to date. I can go to antivirus. If I'll go to schedule updates, here I can see that IPS, antivirus, antibot, and application control are all scheduled to have a daily task to run the update at 1 a.m. But if I want to, I can always go and click Update Now and update the device right now. Policy, by default we're using the recommended policy, logging everything that happens, protection activation, so vulnerabilities that are at high confidence will be prevented, medium confidence will be prevented, low confidence will be detected. I can go and set up exceptions if I want to. Here I can see the infected device within my network, a list of the IPS protections, modify the engine settings, modify anti-spam, exceptions, and also the SSL status, which currently is disabled. I mean, it's not disabled, but it's not using classic SSL traffic inspection. It's using HTTPS categorization. Thank you for watching, and I'll see you in the next video. Threat Prevention SSL Inspection. By the end of this training, you'll be able to enable SSL inspection and enable inspection by asset type. The SSL traffic inspection inspect traffic that is encrypted by the Secure Socket Layer protocol. All hosts behind the gateway must install the Gateway CA certificate. The blades that are supported are application control and URL filtering, IPS, antivirus, antibot, and threat emulation. However, by default, SSL traffic inspection is not being used, and we're using HTTPS categorization instead, which is filtering specified HTTPS URLs and applications without activating SSL traffic inspection based on the URL in the certificate file. You can easily switch from HTTPS categorization into SSL traffic inspection, but as you'll see in the demonstration, if you want to enable traffic inspection, there are a few things you need to do. First, you need to disable SmartXL, and you also need to deploy the certificate within your clients. When enabling SSL inspection, you can select a bypass policy, meaning certain services or certain networks won't be inspected and the traffic will be bypassed. For example, you can bypass based on the network, if it's a trusted network or an untrusted network. For example, one of your wireless networks. So you can say that any traffic coming from a trusted network would be bypassed. Or to bypass based on a category. So if the user will browse to a financial website, traffic won't be inspected and it will be bypassed. I've switched to my 1590 appliance. I'll go to Access Policy, SSL Inspection. Now you can see that currently I'm using HTTPS categorization. If I would like to switch to SSL traffic inspection, I can see this warning. SSL inspection is not supported when SmartXL services is on. So we'll need to press OK, go to SmartXL, and disable it. Once you disable SmartXL, you can go back to Policy and enable SSL traffic inspection. Now, I really like how informative this Quantum Spark is. I really like this comment here. To deploy SSL inspection, download CA certificate and install it on the hosts. You can click on download, and here's the certificate, which you can later go ahead and install it. And if you click more info, you can see that to enable outbound HTTPS traffic inspection, follow these steps, and you can see these specific steps showing you how to do that. Press close, and let's talk about this setting here to inspect based on the asset, meaning do I want to inspect desktops, laptops, or maybe select specific assets. And for example, IP phones and whatever it is that you like from this list. So you can select to enable SSL traffic inspection, which categories you want to bypass, which sources you want to bypass, and also if you want to bypass or inspect based on the asset that's being used. And if you want, more information is available in SK 12.12.14. Thank you for watching, and I'll see you in the next video. Networking configure interfaces. By the end of this training, you'll be able to configure network interfaces on your Quantum Spark. Once you have this beautiful device, you would probably want to configure your local network. So the first thing you'll do is to configure DHCP. The SMB can support the DHCP protocol, meaning it will assign IP addresses to any device with an interface configured to obtain a dynamic IP address. By default, your subnet would be 192.168.1.0, and of course you can go ahead and modify it to match your actual needs. You can configure each port to act as part of the same network, meaning same LAN, or you can split it into separate networks. So either this will act as a switch or as different networks. On some of the devices, you can customize a specific port to act as a DMZ port or just another port on your network. The Quantum Spark can also support VLAN as well, so you can configure a VLAN interface if that's what you want to use within your organization. back on my appliance. From the device internet, I can see the external interfaces. In this case, I have two. One was connected directly to WAN, and the other one is connected over cellular using a SIM card. I can see one of them is connected and active, the other one is disconnected. If I'll go to local network, I can see that I have a LAN 1 switch. My local subnet is 192.168.2.1. Subnet mask is 24. And here's my MAC address. And out of those 8 ports, I have one port that is being used. You can see the status right here. And at the moment, all of these ports are part of the same network, which means if I'll take a printer or a TV or just another computer and plug it into this port, it will be part of this same network. Now, if I want to, I can go to Edit. I can select which ports will be assigned to this network. I can check them in and out. I can configure the interface configuration if I wanted to act as an unassigned network or as a separate network. I can configure the local IP address, the DHCP settings. I have additional DHCP settings, for example, which DNS address to assign all of my DHCP clients, which default gateway I want to provide them, the lease of the DHCP. So 4 hours here, but you can go ahead and modify it and customize other settings as well. I can see that at the moment the DMZ is a separate network that I have here. I can go ahead and add a VLAN interface if I want to, a virtual access point, a VPN tunnel, and other configurations as well. I also have the wireless network here. In this case I have two. It's pretty small, but it's the 5 GHz and the 2.4 GHz, but we'll discuss this in a separate video. If I'll go to my Windows client machine, I have all of these network interfaces right here. If I'll go to this one, this is the interface that I'm using to connect to the actual device. I'll go to Details, and I can see my MAC address. I mean, this is the MAC address of my laptop, but look at this line. Who is my default gateway? 2.1. 2.1, that's my actual appliance. So here I can actually see who's my default gateway. In this case, the SMB Quantum Spark device.
Thank you for watching, and I'll see you in the next video.
Networking, enable wireless network. By the end of this training, you'll be able to enable the wireless network and monitor other access points. On the appliance, I went to device and wireless, and I can see that I have the 2 radio bands available. The 5 GHz is configured but disabled. The 2.4 is not configured. So let's start with that. Configure, select the name. I've configured the network name, protected network 2.4, so people would know that this network is, well, it's going to be slower. The security type, my authentication is using a password, and the password is going to be whatever it is that you want. Press apply. If I'll go to edit settings, I can see the name again. I can change it if I want to. I can see the security type, the encryption type, the password. Now from this page, if you want, you can generate a new password, which is going to be much harder to guess. Here from the wireless network tab, I can see the DHCP settings, the subnet that will be used, access policy, allow access from this network to local networks, or you can disable it, other DHCP settings, and advanced. Press apply. In this case, I've modified the password. I'll enable the 5 GHz radio, and since I'm enabling these networks, my Watchtower application keeps popping with notifications because now there's a new network available, so it tells me about everything that's going on, so it's interesting. I can go to password protected. I can modify only the password if I want to. Press cancel. I can go to edit settings, see those settings again, same settings, of course. If I'll click here, this settings on top, this is the actual radio settings. So if I'll click on that, I can see the frequencies that will be being used, the transmitter power that will be used. I can run a schedule when this network will be available. So for example, it can only run during business hours if you want to. Now that I have enabled the wireless networks, if I'll go to local networks, I can see those networks right here. I can see the subnet that is being used. I can see that they're up. And if I'll go to logs and monitoring, under wireless active devices, I'll see nothing. So let me go ahead and add the device. So I've connected my personal computer to the wireless network. So I'll go and hit refresh. And look, there's a new device on the network. Daniel's Air. The network that it's connected to, the channel that's being used, the frequency, the signal strength, and everything. It detects that this is Apple. Next, I can go to access points. Now, unlike the previous display that we saw, the previous display was show me all of the devices that are currently connected to my network. This shows you all of the access points surrounding you. So you can see your neighbors, you can see other cafes, other businesses that are surrounding you. This is good if you want to see, for example, if there's any noise. Maybe there's another network close to you, and maybe they're using the same channel. So usually it's automatic, the channel selection, but still, this is great data. And if you're familiar with wireless networks, this is a page you want to see just to better understand the wireless networks surrounding you. So this is a great page, but if you want to get an information, you need to make sure that your wireless networks are enabled. And at a glance, I can see that here I'm using channel 11 and here I'm using channel 40. Right at a glance, so this is really nice. And you can also see that 16 adjacent access points use the same channel. That's why the 5 GHz is usually much better.
Thank you for watching, and I'll see you in the next video.
Networking enables cellular. By the end of this training, you'll be able to enable the cellular connection on your appliance. Enabling the cellular connection is really easy, but when you think about it, everything is easy when you want to configure your Quantum Spark. Based on the model you're using, it can support 1 or 2 SIM cards, so you can use several connections. In this case, I only have 1 SIM card, so let me show you how easy it is to configure it. We'll go to Device, Internet, Configure Internet. The interface that I'm using is not WAN, it's actually the cellular connection. Give it a name, press Apply. And here we go. I have an active connection. I can see that SIM1 is connected to Cellcom and I have a 4G connection. 0% failures, the latency. I can do connection monitoring and see connections going to Google, Cloudflare, and OpenDNS. I can monitor the cellular modem itself. It's nice, I can see the temperature. And you have lots of useful information right here. Press close. And now that I have internet connection, I can show you another cool thing, which is to fetch the license. So I can do activate license. And because I have internet connectivity, I'll be able to get my activation file from the user center because I have internet connection and my appliance is registered. New license was obtained. Press OK. And now I have a license as well.
Thank you for watching, and I'll see you in the next video.
Reach My Device Configuration. By the end of this training, you'll be able to configure Reach My Device. Reach My Device service allows you to remotely connect to the appliance from the internet so that you can use the web UI or CLI when necessary. This is done by tunneling the administrative UI or CLI connections through a Checkpoint cloud service. Such configuration is very useful in instances where the appliance is behind NAT device or firewall and cannot be reached directly. In addition, the feature makes it easier to access an appliance with a dynamically assigned IP address. When the security gateway enables the Reach My Device service, an outgoing tunnel to the Checkpoint cloud service is established with the appliance IP address. The gateway registers the application server, receives ports and the SSH server hostname, and then opens the SSH tunnel on the SSH server on the specific ports received. If I'll talk about my own home appliance, I don't have a public IP address. I have a dynamic IP address that I got from the ISP. And if I want to reach the device from anywhere around the world, I'll need to enable Reach My Device. The service is free and it's so useful. Let me show you how to use it. From the appliance, we'll go to Device Access. At the moment, I am not registered to use the service. I'll need to do Register. I'll need to select some sort of a unique name. For now, let's use this one. This is a random name, so it's going to be available. And let's just use this one for now. You can see that there is an option to register with an existing hostname. I'll do that later. For now, I'm going to use this one. If you change the hostname, all Watchtower mobile app users must pair the mobile devices again. We'll talk about that later. For now, let's hit apply. And I'm connected. This is my hostname. You can see those unique URLs that I'll have. A validation token. So now I can go and click this. And here's a cool thing. Regardless of the network I'll be connected to, this link, this specific link, will take me to my own appliance. So I'll be able to manage it from wherever I am around the world, as long as I'm connected to the internet, of course.
Thank you for watching, and I'll see you in the next video.
Reach My Device Reuse Name. By the end of this training, you'll be able to reuse Reach My Device hostname. In a previous module, we've discussed Reach My Device, and we've discussed that once you enable it, you're given a unique hostname by default, and that hostname needs to remain unique, and you can use it to access your device from wherever it is that you want. But what if I'm going to reset this box, and I would like to use the same hostname again? If I would try that, I'll get an error message saying that hostname is already in use, so you can't just take it from someone else. So if you want to reuse your hostname, you need to have two things: the hostname you want to reuse and this validation token. So if tomorrow I would like to set up a new device with the same link, I'll need to type this as it was, because otherwise it's going to be a new name, and then paste this validation token. And if you'll do that, you'll be able to reuse your name. Let me show you. So I've changed the name to test name. I'll go to edit settings and I'll paste my previous name. I'm going to paste my token here, press apply. And now I've successfully configured Reach My Device to use my previous hostname. By adding the validation token, which I have saved aside because I was prepared, I can now reuse the same link that I've used before to manage my device.
Thank you for watching, and I'll see you in the next video.
Mobile Configure Watchtower. By the end of this training, you'll be able to configure Watchtower. Watchtower is a Checkpoint mobile application which you can install on your mobile devices and monitor your security appliance. It gives you a network security snapshot. You can see security alerts, on-the-spot threat mitigations, policy configuration, customized push notifications. You can prioritize event notifications, and simple management of multiple gateways. Let's see how to configure it. From the main overview page, I'm going to pair your mobile device. The administrator I'm going to use is admin. I'm going to generate a QR code. On the left here, you can see my actual mobile device. So if you want to add a new device, you'll just hit the plus. Scan this QR code. And here I can see lots of cool information about my device. I can see that I'm connected to the internet. If I had a VPN, I could have seen some VPN traffic. If I'll go to statistics, these are statistics from the last hour, and I can see how much traffic was being used. And you can also see the security updates. In this case, I am up to date with everything. Wireless network. Let's see if I'll see my actual network that I'm using. So I'm currently connected to this network right here. Status is up. Here's the IP address. And I can see that there are 2 protected devices. Now if I'll go back to the Web UI portal, I can see these 2 wireless devices that are connected. One is my mobile device and the other one is the actual laptop that I'm using. And if I'll go to paired mobile devices, I can see that the admin is connected from an Apple iPhone device, and that's the device I've used to connect to the Watchtower application. Really cool, really useful. Go ahead and install it.
Thank you for watching, and I'll see you in the next video.
Updates, manual and automatic. By the end of this training, you'll be able to update the device and run a manual update. Let's see how easy it is to upgrade the operating system on your Quantum Spark. Straight away, I can see a notification that a new firmware is available. But let's say I don't know about this page. So we simply go to Device, System Operations, and I can see that a new firmware version is available. I'm going to click Upgrade Now. So a few moments later, the upgrade is complete. So now if I'll go to Device and System Operations, I can see that I have the latest version. Now what I've done here was an automatic upgrade, but sometimes you'll want to do a manual upgrade. In that case, you'll go to Manual Upgrade. Next. Select the image you would like to use. Press Open. Upload. Upload finished. Press Next. Next again. And now I'm installing the new image manually. And I can see that the upgrade is complete, and please wait while the appliance reboots. Please do not pull out the power cable. Appliance will be up in about 207 seconds. And when it's done, I'll have a new version of my appliance. And 207 seconds later, the Spark appliance have rebooted, and now I can log in.
And done. Thank you for watching, and I'll see you in the next video. VPN site-to-site. By the end of this training, you'll be able to configure site-to-site VPN. VPN, Virtual Private Networks. There are two main flavors of VPN. One is remote access, where you allow endpoint devices such as mobile devices and laptops to connect securely to your remote gateway. And the other one is site-to-site, where you have two gateways, maybe on two branch offices, and you want to establish a secure connection between those two. So in my network, I'm going to have two Quantum Spark boxes on my so-called WAN network, and I'm going to establish a VPN connection between those two sites. It's all done using the web UI. It's graphic, it's very simple. Let's have a look. I'm under VPN sites and I'm going to set up new. Setting up VPN requires you to set up both sites. I've already set up the remote site, so once I set up this, VPN would be running. Here, I'll need to set up the IP address of the remote site. The pre-shared secret we've agreed on. As for the encryption domain, I'm going to use the routing table. Now, if you want, you can modify the encryption or other advanced options, but for now, I'm going to stay with the defaults and hit apply. And as I mentioned, since I've already set up the other site, you can see that the tunnel test finished successfully. If I'll go to VPN tunnels, I can see there's an active tunnel. And if I'll go to my Watchtower app, click VPN, and I can see that there's currently one VPN site active.
Thank you for watching, and I'll see you in the next video.
VPN remote access. By the end of this training, you'll be able to configure remote access VPN. VPN stands for Virtual Private Network. It has two main flavors. One is remote access, when you allow remote users using laptops, mobile devices to connect securely to your remote gateway. And site-to-site, which allows two remote gateways to communicate with each other securely, setting up a virtual private network. In this video, we'll discuss the remote access. I really like this menu from the web UI because it summarizes all of those different VPN flavors we offer. Each setting has a simple checkbox and the instructions telling you how to set it up, with even links to applications, and everything you need is right here from this menu. So we'll jump to the web UI and show you how to do it yourself. So what we're going to do is we have the Quantum Spark on our artificial WAN network, and I have a few mobile devices on this WAN network, and I'm going to connect over VPN to my Quantum Spark. From VPN, Blade Control, I'm going to enable Windows VPN client, set up the pre-shared key. In this case, it's going to be VPN 123. And if you'll click how to connect, you have all the information you need right here. Same goes for mobile client, Checkpoint VPN clients, or an SSL VPN if that's what you're fancy. Same goes for Checkpoint VPN clients, mobile client, SSL VPN. Just enable it, follow the instructions, and you're good to go. One more thing I'll need to do is to set up a user. So I'm going to Remote Access Users, Add. I'll set up the username, password. I can set up email, phone number, and other comments as well. Press Apply. As you can see, I have mobile client enabled, which enable VPN remote access mobile clients to connect via Checkpoint mobile VPN client. On the right, I have my mobile phone, so I'm going to my business applications, Capsule Connect. I have the username, SimpleRick, my password, and you can clearly see that I'm connected. And if I'll go and see the connected remote users, I can see SimpleRick is indeed connected. This is another laptop that I have, and I've set up SimpleRick to set up a VPN connection. I've added the gateway's IP address, my username. And now all I need to do is to enable VPN. And you can see I'm connected. And here's my remote connection. And back on the Watchtower app, I can go to Internet, VPN. I can still see the site-to-site VPN tunnel. And if I'll go to Users, I can see SimpleRick is connected from 2 different IP addresses. From the Logs and Monitoring tab, I can go to VPN tunnels. Here's the site-to-site VPN tunnel that I have. And to see the remote VPN users, I'll need to go to VPN Connected Remote Users. And by the way, to add the user, if I were to have Active Directory enabled, I could have just used the Active Directory users as the remote VPN users as well.
Thank you for watching, and I'll see you in the next video.
Monitoring. By the end of this training, you'll be able to use the Monitoring tab to monitor the network environment. Here I am in my 1519 appliance, and we'll just go over all of these settings right here. First, we have the security logs. So any security incidents you'll have regarding the policy will be shown here. You can run queries, refresh, clear the logs, and other cool stuff. We have system logs. If you were to have any external log servers, you'll be able to configure them right here. Notifications. So personally, I get these notifications on my Watchtower app, so it's really cool. Active devices. These are all the devices that are currently connected to my Quantum Spark. Wireless active devices. I have 2 right here. Paired mobile devices. So if I were to have any users who are using Watchtower, I would have seen them right here. In my case, I've reset my appliance, but if you saw the Watchtower video, you saw the device was there. Infected device, currently I don't have any, I'm good. VPN tunnels, if you were to have any VPN tunnels, you would see information about the tunnel right here. Connections, I can see connections going through my device. Access points, if you have the wireless networks enabled, you can go ahead and scan networks in your area. If we'll go to monitoring itself, here we can see information about the current connections. We have a breakdown of the different applications that were being used. I can go and switch to categories instead, and I can see instant messaging, general search engine, and so on. I'll go back to applications. We can change to sites, users. In this case, I don't have user awareness, so it's just 100% same thing. This is nice. You can see traffic over time, reports. I can go to demo here as well. And here just have a little bit more information, so it just looks nicer. I'll go back. And if I'll click here, it can also take me to do some troubleshooting, meaning to show me monitoring about the actual CPU, memory, and disk usage. I can hit refresh, and I can start seeing those live graphs about the memory usage and CPU usage, and also disk here below as well. Click on reports. You get nice reports about the traffic that was being used. Really nice. Can be useful as well. You can print it straight from here. Really, really nice.
Thank you for watching, and I'll see you in the next video.
Troubleshooting Tools Overview.
By the end of this training, you'll be able to use the diagnostic tools to collect valuable data and generate reports. Back on my 1519 appliance, I'm at the Device Tools tab, and from here we have lots of small tools which can be useful for troubleshooting. For example, monitoring the system resources. I can hit refresh, and then I have CPU usage, memory usage, and disk usage live, really useful. Show the routing table. Now, of course, you can also just open up a command line and do that yourself, but it's nice to have it in a graphical method right here. Router configuration, for example, for OSPF, which at the moment I have nothing. I only have the area enabled, but later on, if you'll have OSPF enabled, you'll be able to see that information here. The test cloud services ports, which will verify that the appliance could connect to cloud services. You have a graphic TCP dump tool, where you set up like a host, a port, and then you'll see it here. DSL statistics. At the moment, I don't have any. I'm not connected over DSL. Monitor the cellular modem. So I can see 4G, LTE, signal strength. I'm using SIM1, SIM2 is not available, temperature, and other cool stuff. This will generate a CP info file, which you can later send to your technical support or someone to help you figure out if something doesn't work. So just click on that, it will generate the report, and later you'll be able to send it over to whoever it is you're working with. You can also generate Dr. Spark. Dr. Spark is a cool utility that generates lots of useful traffic regarding Spark and help you troubleshoot if something doesn't work. And there's also the Dr. Spark load as well, a performance test in this case, useful tools. You can send a ping straight from here. So yes, you can open up a CLI window and run a ping, or you can just do it from here. And in this case, the ping works. And a DNS lookup as well. You can also download a USB-C driver for your appliance, so you can go ahead and have a console connection to your appliance. In this case, the Dr. Spark performance report is ready. I can click download, and it will download this report. Same for CP info file. And now I have these files ready.
Thank you for watching, and I'll see you in the next video.
Troubleshooting backups. By the end of this training, you'll be able to create a backup file and restore a backup file. From the Device tab, if I'll go to System Operations, there are a few very useful utilities you can use here. First one is to just reboot the appliance, restore to factory default settings, but the firmware will remain as is. Factory defaults revert to the factory default image and settings. In this case, my factory firmware version is R80 2015. Firmware upgrade, so you can do check now to get an online upgrade from the Checkpoint servers, or you can do it manually. We've done this before. Revert to the previous image. In this case, this is my previous version, and set up a backup. So I can create a backup file. I can encrypt it if I want to. And tomorrow, if something didn't work, I want to revert, I've messed something up, I can always just do restore. Browse to that file and restore if needed.
Thank you for watching, and I'll see you in the next video.
Networking dynamic routing. By the end of this training, you'll be able to enable OSPF on an interface. When you talk about dynamic routing, there's so much to discuss. It's a very efficient way to build your routing table in a dynamic and automatic manner. So you need to enable the dynamic routing protocol, configure it, and watch the magic happens. When you think about dynamic routing, OSPF and BGP are two common, very useful dynamic routing protocols that come to mind.
In this demo, I'll show you how to configure OSPF on your Quantum Spark. For the purpose of this demo, I've already set up a Checkpoint security gateway running OSPF, and what we'll do here is I'll set up the Quantum Spark to establish neighbor relationship with that router. Going to OSPF, add an interface. So I'll be using LAN 1, area 0. I'm going to keep the intervals as default, 10 and 40. This is not going to be a passive interface. Press apply. And now, if I'll go to the routing table, and here it is. Look at this beautiful route. If you want to reach 10.1.1.0/24, your next hop is this address. And this is an OSPF protocol. It's a dynamic route. And all I had to do was to just configure OSPF. And the cool thing was, I've configured OSPF on the Quantum Spark using a graphical interface, which is such a relief, actually. That's really cool. I really love this feature, and I hope you'll take the time to do it yourself.
Thank you for watching, and I'll see you in the next video.